Hi there, good afternoon everyone, and thanks very much for joining our Ask Me Anything webinar today. My name is Yalda and I'm one of the account managers for the design solutions at Causeway. I've been here for a little over 4 years, and during that time I've been working quite closely with consultants, house builders, and local authorities, water companies, helping them achieve their design goals whilst also designing as efficiently, creatively, and sustainably as possible. So today I'm joined by Dr. Net Mabrate, a product owner at Causeway, who is heavily involved in Causeway Flow's strategic roadmap, development roadmap, as well as supporting the training and any technical teams as well. So why did we decide to run this webinar? Well, last November, we hosted a webinar that was titled Deep Dive into Causeway Flow. Is Causeway Flow the right fit for you? And during that webinar, Net gave a short demo and a Q&A session at the end. Throughout that webinar and then following the webinar, we had an overwhelming response, a whole bunch of questions. So we thought, why not host a specific Q&A or Ask Me Anything with Net himself? So we had a forum open for a few weeks before this webinar, and everyone submitted questions beforehand. Thank you very much to those who did. We've all got together and had a quick look through, and I think it's fair to say we've got some really great ones to get stuck into. But if you haven't submitted anything beforehand, don't worry, there's should be a control panel on your right-hand side, and you can submit any questions via the Q&A box there. So today, we're going to do our very best to answer as many questions as possible in the 1 hour that we've got scheduled. These will obviously vary in time. Some of them are simple yes or no questions. Others require a little bit of a demo. So we're going to range them from a minute to, I'd say, maximum 10 minutes per question. And I'm going to be that annoying person keeping tabs on the time just to make sure that we don't run over, because we really want to answer some of your live questions too. So if we do run out of time before we get to your questions, please don't worry, we'll be sending any questions and answers over to your email address that you've registered with. So you shouldn't have to worry about that. You'll be getting that within a few days alongside the recording of this session as well to refer back to. So before we get started, Net, do you want to introduce yourself a little bit?
Thank you very much, Elda. And I'd like to say before I start telling you about myself, really appreciate your attendance and your dedication. So thank you very much. My name is Net Sanet. Everyone calls me Net, so feel free to call me Net. My background is academics, mainly in terms of scientific computational analysis, so mainly focusing on hydraulics. And basically around 2007, I joined Microdrainage as a product owner and worked until 2016 before I joined Causeway to work on Flow as a product owner. So most of my life has been, really my career at least, has been in drainage design softwares and how to obviously make your life as smooth and as easy as possible. And that's briefly about myself. Given there's going to be a question and answer session, I just think it's an important point to make that we really thrive on your feedback and your continuous support in encouraging us to build a software to be as useful, as productive, and as essentially less painful as possible for you. So it is important to continue to give us your feedback, to continue to innovate and improve the software that you use for drainage design. So I really strongly encourage you to continue to help us with your feedback and give us your honest opinion. And yeah, that's about me for now. I will suppose go into the Q&A session now.
Yeah, great. Thanks, Net. So there's just under 100 people live at the moment. So we're going to get started on the questions that were submitted beforehand. Yeah, keep the questions coming along, and we'll try and answer as many as possible. Let's jump into it, because we've already five precious minutes have gone. So yeah, let's start with the first question. Okay, so we've sort of had a few that we've grouped together, so they've got a similar topic behind them. So a number of these questions were around outline, concept design, detailed design. We've got how can overland flows be captured in a model, digital terrain models and elevation models, and then summarizing the equivalent of source control from micro drainage. So Net's going to answer all of these in the next 10 minutes through a demonstration.
Okay, thank you very much, Elda. Let me share my screen. I think I need to be a presenter first, so just request. Yeah. So hopefully you should be able to see my screen.
Yeah.
So really important questions to do is overland flooding analysis, ground modeling, pre-development assessment you could do for a site. We grouped them together because there are things that work within the Flow software as well as the other graphical tools that we have. So I thought I'll just group them together so we can be able to kind of like methodically go through design processes that you'll do. So before we start, it's a good point to make that there is a product called Live Design that allows you to do ground modeling, road design, alignment design, drainage design, overland, flow analysis, traffic management system, all integrated holistically. So as you basically go through adjusting one, everything else will be cascaded, etc. So that's something work in progress. But to answer one of the specific questions about how you can be able to incorporate ground models, you can use obviously ground modeling tools, and that then means in the background you'll have the ground model. I'll show you a bit later about smart tools, smart surface, where you'll be able to also provide surface level elevation data for your drainage system. We also have something called PDS. For those of you who are already aware, I'm pretty sure you know it allows you to be able to do road design as well as ground modeling in more detail than what Live Design does give you capability for currently. So you can either originate from any of those three tools, then that basically means the ground model will be part of your drainage system. That's one. Dealing with the overland flooding analysis, which is obviously where I think I can demonstrate more effectively what you could do, given we have the ground model. At the outline stage, when you do an outline preliminary assessment of a site, it's obviously a good idea to look at what the discharge rate is going to be based on pre-development round of calculations you can do. But it's also important to look at what is going to happen when you have rainfall that lands on your site, where the natural blue-green corridors are, where are the natural channels where the water is going to be gravitated towards, what in order to be able to understand the existing terrain and make effective decision basically. And generally we can use what's called a two-dimensional hydraulic model, and it depends on what type of hydraulic model that you can use, but the model we chose allows us to be able to simulate flood inundation data basically, or a surface with a computationally effective manner, and it considers also really complex topography because we are aware you are going to likely design in an urban environment where there's going to be curves and twists and turns, etc. So that's the background, and I don't want to go in too much depth. There's a lot of material we can share with you if you're interested. But basically, just to do an overland flow analysis, all you have to do is basically make sure you have a land use setting that allows you to be able to kind of like set up things like what type of land you're going to have, whether you're going to have something like roughness, whether something like evapotranspiration, percolation rate, infiltration, etc. that can be basically applied per the zone you are going to zone in your site. And you'll be able to also have what we call styles, where the display that is going to be generated is going to be generated so that you obviously have a specific depths associated with a specific type of color, and you have the chance to be able to adjust the depths and the velocity as well as the hazard bands. So all of this is something that can be adjusted, and all you have to do is basically select an add button, and then that then add allows you to be able to add basically what we call analysis area, and that analysis area basically then can be adjusted. You can move it about, adjust it. You have the chance to be able to also adjust things like the boundary conditions, whether you're going to have a closed boundary, open boundary, etc. And you then have the chance to be able to run overland flooding analysis. If you run an overland flooding analysis, it gives you the chance to be able to adjust things like the resolution, whether you're going to have a fixed rainfall in millimeters, or you're going to have obviously specific type of rainfall profile that's going to be applied on the site. You can also use the synthetic rainfalls, and you have also the chance to be able to specify things like the drain down time, how long it's going to run for, and what type of analysis speed it's going to be run for. And once you have done that, it takes a little bit of time. It gives you the chance to have an overland flow route for your site. That then means you obviously, again, you can look at what type of velocity, what type of depth is generated, where the
Sorry, let
likely
me message.
flow.
Okay, he's back. Sorry, Net, you just had about 10 seconds of delay there as the overland
Okay.
as the analysis was running.
Okay, sorry about that.
Screen's back now, so you're all good.
Yeah, it's I don't know. Sorry about that. So like, it just allows you to be able to obviously run an overland flow routes where you'll be able to identify what's called blue-green corridor, natural hydrology, where the water is going to be gravitated towards. So you can pretty much use that as a tool to be able to decide where you could place your sustainable drainage structures, etc. And that's one of the things that is worth mentioning. If you have something like flooding from a really already drainage system that you have done, so you might have already like a completed drainage system, and there's going to be flooding, and that flooding needs to be demonstrated to be contained within obviously safe zones or public open spaces, things like that. You have the chance to also run overland flow routes based on the flooded volume. So you should be able to essentially run what we call flooded volume that is going to be associated with the critical storms that basically cause those floodings. So all of that is something you can do from overland flood analysis point of view. From the outline drainage design point of view, what you could do is use what we call Sketch. And if you notice actually in Flow, the way we structured the design tree view on the left-hand side is essentially to follow the pattern that you'll be able to use when you do design. So if you look, Sketch comes first, and then simulation settings, and then the detailed design. And that is on purpose because Sketch is something that allows you to do an overview, or think of it as like, things like preliminary outline, concept design of a scheme for your site. So that means you will be in a position to be able to kind of like have a good idea about the sizes and dimensions and the structures and the discharge limitations that is going to be imposed and what type of capacity you should be able to provide and so on. So that's something you can do by cascading structures. In simulation settings, you could also do greenfield runoff rates, brownfield runoff rates, runoff volumes, etc., which I think there's going to be a question later, which I'll discuss. And in Sketch, you can just be able to, drag and drop storage structures. I've kind of like done a couple of them just so you could see. And one thing I've done is, because there's a question about soil design, you'll be able to essentially design a link type as a swale, which is something you can be able to design freehand. So things like basically the dimensions, the bed widths, the height, the auto increment, the side slopes, and the preferred cover. So you can be able to essentially associate it with the ground. If you select follow ground, if you have the topography as mentioned in the question, that should automatically snap into the surface for you. You have the chance to be able to also adjust things like the Manning sign for the roughness associated with obviously the things like the vegetation and gravel material, and there is a good guidance on the sets manual as well as other documents to look at what type of mannings to be applied. So you could basically then create something like that, just so you could see, because you could technically create any type of network, any type of sustainable drainage system, and these are the things that we'll be able to look at today, so that we can see all the range of options that you have. That option should be available.
1 minute left on that net.
All right, okay.
Thanks.
Thank you, Yalda, for the reminder. That allows you to be able to kind of like create the swale by just clicking an option, and that's something you could do with all other structures as well. This is just an example, and this then allows you to be able to specify things like the name of the node and the cover level. Let's say I have something like that for the cover level. And you can be able to then specify things like the lengths, because there is no coordinate or there is no concept of dimensions in a schematic view for outline design. Obviously, you could do that in Live Design or PDS or Smart Tools. That basically is something you need to be in control of, and that allows you to be able to do that. And you'll see the swale will be automatically be designed, and you'll be able to also specify things like, contributing areas as a node, or contributing areas as a lateral link. That basically is area coming in along the length of a link, like an open section. And this is something that means you will be a little bit closer to what happens in reality, obviously. And you can adjust things like the slopes and so on by manually adjusting the level, so you can automate that. And once you have done that, you can also specify things like infiltration rate. So you can apply infiltration rate for the swale or any type of structure, which we'll discuss in more detail a bit later, because we have quite a few questions on that. And that basically should turn into a different color, that, to show you we have a green infiltrating structure, basically, if you have an infiltration. And that then means you can obviously analyze the network. One of the most important points to do is obviously the outline design that you could do is, because it's going to be linked with the full hydraulic engine that basically is capable of modeling anything to do with 1D system, reverse flow, backwater, pressurized flow, surface bonding, surcharging, etc. It gives you basically the chance to be able to model the outline design as accurately, right? So you don't really have the limitation of basically assuming the downstream storage structure will be oversized because there's no concept of backwater. In this case, there's going to be a backwater, definitely. And you'll see that, obviously, when the water reaches a certain level, you'll see the hydraulic gray line will be straight. And that basically is a sign that, obviously you have backwater and reverse flow, etc. So that's something that means the hydraulic analysis and the results that are going to be generated, and the volume and the capacity that you are able to kind of like capture, will mean you have the confidence when you turn this into detail. There isn't going to be any surprise. There isn't going to be any obviously major change in the capacity you need to provide. So all the structures that you can think of can be designed this way as an outline concept design, or you can obviously use a similar concept for the detail design, which I'll show you a bit later as well as an example. Okay. But for now, I think that should be able to kind of like capture all the 4 questions.
Whistle-stop tour there of the outline and a sort of preliminary design. Thanks very much. Probably important to note that we're showing you what's possible here. If any more detail is required on how to actually action these, then pop it in the questions, contact your account manager, and we have specific tailored training courses on all of these topics as well, which shows you a bit more of a step-by-step guide on how to actually go about these designs. Okay, next question. I want to design a pond and connect it to another pond. Is it possible?
Yeah, and I think probably with this question, we'll have example later, but yeah, you can is answer. Not only you can by using a link, you could actually have something like overflow loops as well. As you saw in the outline design, you could actually connect structures using a weir or office or something like that, which means technically there isn't going to be any time of concentration, or there isn't going to be any time of travel. There's no concept of obviously water inflowing and outflowing from a structure, so that connection could just be volume transfer. That's the easiest way of doing that, or you could actually connect them using links between the ponds. So that's something we could have a look at later.
Yeah, brilliant. Okay, thanks, Net. Okay, how do you model submerged outfalls?
Okay, that means probably need to share my screen. So let me share my screen again.
Right, time is going on again.
Yes. So submerged outfall, that's something I prepared earlier. This is basically a cascaded system of sustainable drainage systems that you could do. This is not, this concept design is actually detailed design. What you could do is, if you go to hydrographs, in hydrographs there's many options that you could actually basically use to adjust the inflows or the outflows. Basically is to do with affecting what is going in and what's leaving the network. And I'll deal with what the inflows a bit later, because we have a few questions to deal with that. But when it comes to the outflow, the surcharge outflow, specifically the question about submerged outflow, if you want to essentially adjust the outflow, what you need to do is select the surcharge outflow, specify the duration of how long it is going to be submerged for, or you could actually specify any random one. It doesn't matter. The main thing that matters is the time step in what you put in the depths. So the time step is going to be essentially, if you have changes, if you have differences, like in this case, I just block the outflow. Basically, the outflow is 1.649. You have a small pipe diameter, so that basically means, as long as the hydraulic head is at that point, it will block the outflow. And that's going to be blocked for 780 minutes, for example. This is actually a very active kind of like project that I help support. That basically was a drainage system that is discharging into a coast, and they were told there is going to be basically a tidal wave that closes the discharge for about 780 minutes. So what you could do is just say, you know what, I'm going to close it for 780 minutes by making sure that depth is obviously close to the cover level. That means you always assume there's going to be a flap valve at the outflow. So that means it's going to close the flap valve for the 720 minutes. So when you run the analysis, you'll actually see the discharge is going to be 0 if you have like a smaller than 780 minutes, and then you'll see, like obviously in this case 240 minutes, you'll see there's 0 discharge there. And the moment we kind of like go beyond that, you'll start seeing obviously discharge that's going to appear after the 780 minutes, as you can see. So there's going to be discharge generated. So that is the easiest way, and you could obviously vary, and depending on obviously whether you have a full idea about the submerged outfall data that could be provided by EA, or obviously people who are going to manage the reverse or coast, or whoever the approval body is going to be, you should be able to have that information. So you could actually use a copy paste mechanism, right? So any of the spreadsheets you see in Flow, you could copy and paste to by using Control C, Control V. So not only obviously the hydrographs here, but you could obviously copy and paste your networks as well, if you like, right? So you should be able to transfer any information you have about the submerged outfall that you need to simulate as well. So that's how you do submerged outfall.
Perfect. That's great. Should we go on to the next one?
Yep.
Okie doke. So yeah, lots of SUDS questions before the webinar that we received. I suppose it has something to do with the Schedule 3 announcement. So understanding what kinds of SUDS measures can be modelled. Can you set up a rain garden simulation on Flow, and green-blue roofs? So lots of different types of sustainable drainage systems. All are possible in Flow. Net, can you show us how?
Yeah, I mean, obviously I cannot cover every single thing that is listed here, but I think we can safely say, I can show you something like a rain garden. There are different ways. Like the main thing to recognize about flow is when it comes to sustainable energy systems or any type of storage structure, you could actually design them using very few templates that we have. I think this is something probably we will need to ask your feedback for. So if you have a very strong opinion about having to have a template, please let us know. So because we are considering it, so that would be important to know whether you really want a template. But so far, our approach has been to make it as open as possible. So you could be able to kind of like design the traditional way, where you'll be able to place like storage structures like a depth area, which allows you to design anything. Then soakways, line soakways, car parks, board soakways, which are basically templates, basically that allows you to be able to have specific type of structures, and everything else which should be captured within that. But it's not obviously sufficient to just say, that should be the way you design it. We kind of like opened it up a little bit as well, because we have something called flow through pond, and we have something called link types that allow you to be able to design the shapes and sizes. So this is one of the things that allows you to be able to, for example, design something like a rain garden. So you'll be able to kind of like create the shape similar to what we have done earlier, and be able to kind of like design things like rain garden. You could incorporate it as part of your main drainage or detailed drainage, if you like, but I'm just showing you here. And you could essentially, if you do it as a link, it means if you have a different porosity rate, you'll have to consider that as a porosity by resizing the shape. The other way, and just before I actually conclude that, it should also mean you'll be able to make that infiltrate, right? So similar to what we have done earlier, you can apply infiltration rate, etc., to a rain garden. But you could also use what I call a flow through pond, right? Flow through pond is one of those important structures that is worth talking about, because even though it says it is a pond, think of it as a flow through any structure, because it allows you to be able to create any shape you like, right? So if you basically say you have a shape that is going to look like, let's say this, just outline it. You could outline the shape, by the way, in Smart Tools, in Live Design, in PDS as well. And as you go through outlining the shape, it will actually be updated for you. It allows you to be able to have, as you can see, the inlets in the true geographical location, the outlet in its true geographical location. You should also see something like main channel lengths, average slope, and Mannings, the roughness associated with obviously the different types of vegetation and gravel material you could have. So you could use these as well if you like, but you could obviously shrink the size and create the shape. And that also means you'll be able to specify things like the porosity rate, etc. Right? So that is something you could use as well as a rain garden, just so you could see. There is also a question about blue roofs, green roofs. Then one of the main important aspects of things like blue roof, green roof is to consider what is happening to the rainfall before it gets into the drainage system, basically, to either be stored in a crate or it goes into the downstream end. And there is obviously what I call blue roof, but think of it as basically, because you could interchangeably use it in some instances. There isn't a specific guidance out there. That's the reason why we don't have a specific template to say this is how you should use it. But what you need to consider is, obviously, if you want to consider the elongated inflow, because the water has to percolate through different membranes, soil or other manufactured membranes, that what you have to consider is an elongated inflow. And that is something you could do by going into hydrographs and adjusting the time area by specifying the duration and the time step. You could also specify things like depression storage, evapotranspiration for the losses that basically take into account the depression. There is also possibility to ignore all of that and essentially assume you have saturation, worst case scenario, and you just say, you know what, there's going to be just some depression storage in evapotranspiration too, without an elongated inflow. And that's, you know, anywhere between the two is basically the right approach. And hopefully there's going to be a guidance soon, because I know they're working on it, Syria is working on it. So once we have that, we will definitely have an authoritative guidance so we can be able to implement it in the software. So we're waiting for that basically. Nowadays with blue roofs, there is something called crate that you could put on the roof. I don't know if you are aware. So that basically allows you to store the water, and you'll be able to specify that as a car park, or you could obviously use any of the other mechanisms as I showed you, but this allows you to be able to kind of like represent the storage capacity you have on the roof, and you can obviously, you know, limit the discharge from the crate as well using flow controls. So those are really like the main approaches, but obviously the devil is in the detail, and this is something we can obviously go through when we have a little bit more time. But it is possible, as you can see, to design any type of blue roof, green roof, but you just need to have an understanding on how the software is, you know, able to work instead of a template to look for, right? So that's the main thing to really remember. There are obviously many different ways. One last point to make before I conclude is when it comes to things like storage structures that you design, if it is very important for you to make sure the inlets and the outlets are in the true geographical location, not only that representation of what the dimension looks like, it's very important to consider flow-through ponds. Even though, as I said, it says it's a flow-through pond, it's actually a structure. Think of it as any structure, because you could obviously adjust the depth area table and be able to adjust the dimensions. So that should allow you to be able to represent any type of storage structure, basically. So I hope that answers the question.
Thanks, Ned. Just got a live one that's come through that might be worth answering now as
Yep.
well.
Yep.
Does that mean it's possible to model two separate outfalls into a soakaway
Absolutely. Yes.
as well? Okay.
Yes. 100%. Yeah. You could have as many outflows as you like. So there's, I mean, there's a question about Flow Plus, which I'll answer later, but with Flow Plus, you should be able to do what's called multiple outflows. That means actually outflowing into you know, water course or main drain or whatever. But you should also be able to outflow into a soakaway or a pond or bioretention at multiple directions, and that's basically what a flow-through pond considers. So yes, that's correct.
Brilliant. Thank you. Okay, should we go on to the next one?
Yeah. Yep. Let's go for the next one.
Good stuff. Okay, so we had a few questions on smart tools. So can surfaces from Civil 3D be incorporated and then cover levels assigned from these? And then another one around importing surfaces. So yeah, I think that requires another demo there.
Yes, absolutely. So hopefully, let me share my screen, and you should be able to see my screen. For those of you who are not aware of smart tools, we have basically that a module that works embedded in AutoCAD or CV3D. Both AutoCAD and CV3D basically kind of like have the same workflow. The only difference with CV3D is you'll be able to incorporate the surface live, and you'll be able to kind of like import a CV3D network too, right? So that's the only difference, but all the ribbons that icons are the same. So smart tools basically allows you to do an outline design as well as a detail design, as well as obviously drawing production, pretty much everything you expect from a graphical interface. But the beam output is what makes it stand out, because it allows you to be able to kind of have a full beam output that contains all the constituents of your design, not only the hydraulic aspect, but you obviously have the construction aspect, things like the bedding, the surround, the trench size, the backfill, the material, everything, the thickness. So that's something that is important to point out. But coming back to the question, it comprises of smart surface that basically allows you to incorporate surfaces from CV3D, or basically the ground modeling tools that you saw earlier from Live Design or PDS, which you can use by selecting the surface from CV3D option or surface from 3D faces. If it is a CV3D, to answer that question, you should be able to select that, and that basically imports the CV3D surface. If you have it open, it should be live. So whenever that surface changes, you'll be able to also guarantee the surface is going to be adjusted automatically for you too. But if you want, you can also use Xrayf, right? So like any CAD user, so you could be able to essentially Xrayf and import in your DWG file, which I've done here. We have road A and road B. And once you have incorporated the surface, you should be able to essentially demonstrate or show the height map so that you can see where obviously where the surface is and so on. So you'll be able to see, for example, in this case, I have an overpass and underpass, and that's something you could be able to easily understand and visualize, etc. What makes Smart Surface smart is not only that it allows you to load data and stuff like that, it allows you to be able to incorporate what we call multi-surface. So you'll be able to load as many surfaces as you like. You can then combine them in different sets. So you can be able to say, okay, this set is going to be contained within this, it is going to contain these surfaces. So you can have proposed surface, existing surface, and you can layer them up. So in the apps, so you can prioritize them. So you could say, if I happen to have the drainage system at that point, please, make sure you use a proposed surface instead of existing, because I prioritize the proposed. But in the absence of that, you can use existing kind of thing, right? So you could be able to kind of like adjust the priority order, and that's going to be automatically essentially giving you the exact surface that you need. And you can then select the multi-surface here, or you can individually select each particular surface that you have loaded. And what that technically then means is you should be able to kind of like model a drainage system for something like a spaghetti junction. Basically, level separated grade, surfaces, really complex surfaces can be modeled using the surface. And obviously with the drainage system, you should be able to kind of like use smart tools or smart drainage, so you could see how easy it is. You just need to do what we call setup of associating which layers or which line type or block is going to be containing the manholes and links, etc. But this is a drawing that basically is comprised of a polyline, a line, a block, a circle, an ellipse, basically contributing area as a polygon or polyline. Essentially, any CAD drawing basically it can be transformed into a drainage system. So you could select the build update button, specify which one is that for node, and it basically builds a drainage system for you at a click of a button, as you can see. Once you have that, because I have the smart surface as part of the surface, and here's one of the questions we had, how do you incorporate that? You'll be able to say, okay, can I have that exported, and I'll just load that file just so you could see, and then you'll see, obviously, magically, it will transform basically the entire network as we drew them. So you should be able to see the file that we created, and you should be able to see, the drainage system, all right? So you could see the flow through pond, you could see the, things like the contributing areas, everything that we had exactly as we intended it to be imported. And all you have to do is specify things like the character, the design settings. This is obviously something which should be very familiar for all of you. So I'll, for the time being, just do it very quickly, and that then should transform the drainage system, as you can see. Not only that, because I mentioned this earlier, if you want to have, for example, something like a channel at the top and main drain underneath, it will actually transform that exactly how intended. So it essentially allows you not only to have the cover level, things like the cover level, the easting and northing, etc., automatically transferred into flow at a click of a button, but it will actually know where each link is going to be in relation to the cover based on the preferred cover you set. So all of that is going to be automated for you. And that should also mean, because we have the optimization option that allows you to be able to satisfy things like self-cleaning velocity and preferred cover and so on, that you can set it should automatically be satisfied for you too. And that is something we can obviously look at in more detailed sessions, but it gives you the chance to be able to kind of like transform a very simple drawing into a more complex detailed design without a lot of effort, basically. So that hopefully is something that quickly demonstrates what Smart Tools does, as well as the surface part.
That's perfect. Thanks, Net. And there's a one-day training course delivered by Net called Graphical Drainage Design that runs as well, that really goes into the nitty-gritty of Smart Tools and the integration between Flow. So if anyone's interested in that, then get in touch afterwards. Okay, question from Chris. Is it possible to import a ground profile from PDS?
Yeah, I think as you saw Live Design one and Smart Tools one, and the PDS one is exactly the same. So if you basically have the ground profile with a drainage system, it will be imported in, and that should be automatic. Because obviously they are all our products, it should be a lot more integrated, as you'd imagine. So that's what we have. So yeah, yes is the answer.
Yeah, perfect. When will Flow be available to use in Windows 11?
So we have an update coming next month, so that should be where you will guarantee that.
Great, so next month there. Okay, anonymous question, but I've had a conversation with this before. Are you aware of the FEH22 that is going to supersede FEH13 rainfall data?
Yeah, a very good question, and relevant, I think, to also highlight to everyone who's attending. There is FEH22, which was released last month, that should technically be something that supersedes the previous FEH methods. It contains all new data up to obviously up to recent times, instead of what we had in FEH13, which was basically a recalibration of the statistical method, but there was no new data. So that data was between 1970s to 1990s, whereas FEH22 will contain latest data. So not only the statistical method, but the data is also something that's going to be updated in FEH22, and that should be supported in the next release in March. So it's basically next month. So that is something that is being actively worked on. So you should be able to have access to FEH22 in the next release.
Perfect. Okay, does Flow include pollution treatment train and how to work out pre or post development volumes?
Yeah, as you can see, like, you know, we do have quite a solid hydraulic design software, but when it comes to the pollution removal, water treatment train, this is something that we are working on currently. I cannot promise it will be included in the next release, but it should be in the following release. So that's something that will allow you to automatically calculate whether the pollution mitigation index is going to be less than the pollution hazard index, etc. So it's going to be an automated process. It should just be a matter of obviously making sure you have provided the right calibration, pretty much what the total suspended solids, the hydrocarbons, the metals, etc. is going to be. That's going to be treated by the structure, so the inflow, and that should automatically allow you to do that. So that's something we are working on, and it should be available this year for sure. But yeah, that is something hopefully will be ready for the mandatory sets requirement that could be coming in as of next year, which we probably are aware because DEFRA is talking about it. They're preparing, how to implement it. So if that is the case, then that probably will be a useful tool to have as part of that process. So you will definitely make it ready for you.
Yeah, and just on that, once we've got a bit more of a clear idea on that implementation, we'll be releasing a blog post to support. Yeah. Okay. Right. Are there any plans to make it easier to migrate microdrainage files into Flow where there are differences in procedure? For example, the modeling of underdrains.
Yeah, I think I don't think I can be like politically correct here, but when it comes to microdrainage files, we kind of like support importing from micro drainage to flow pretty much as we can. The only limitation is if you have user specifiable link types, which is a bit tricky because our approach is slightly different, as you probably can gather, to what micro drainage does. So that's the limitation, and it's very tricky to be able to automate that because it means you will have to make sure that it does go through a checking process by the engineer themselves. So that's the only point where you'll have to do a check. So that, and it's unlikely we could automate it because it needs to be checked out, because we don't use coordinates like micro drainage does, mainly because the engine we use forces us to kind of like have this dimension based open or closed sections, so you could specify. But having said that, one of the things really important to make a point on is, like, obviously micro drainage is not going to be supported moving forward. So that means we do need to support any legacy data you have, any AMDX, SWS, etc. So that is really important to us. So you should be able to kind of like import any micro drainage file without a lot of problem. It's the other way around, which is a bit of a problem, because as you saw, like, we do have things like bifurcating system, multi-path fold, things like parallel links. You could have structures one on top of each other as links. So if you have something like that, then it's going to be a bit tricky to go the other way around. So that's one of the things, hopefully, you will notice that will be avoided, given micro drainage is not going to be supported moving forward.
Okay, great, thank you. Right, question from Seb. How exactly does the brownfield runoff estimation work in Flow?
Let's do a quick screen share, and then I probably need to kind of like talk around it. So when it comes to brownfield runoff rate, there is what I call best practice, which I think should be essentially brownfield assumes there's existing system already. So the best case scenario will be to model the existing drainage system and basically hydraulically analyze it, hydraulically analyze it, and see the discharge that's going to be generated. That assumes obviously you have information about the existing drainage system, which sometimes might be lacking. In that instance, in the absence of that, you can either assume you are going to use basically a clay type of soil with probably adjusted growth factors to increase the runoff, or you could use modified rational method. If you use a modified rational method, one of the things that that I've seen from a lot of people is you will be able to know obviously what the contributing area is, the percentage impermeability. CV is obviously something that can be adjusted, as you know, but you can obviously specify it. It's a factor. So those variables are easy to know. The most difficult part is the time of concentration, because obviously time of concentration is the time of entry plus time of travel, which is not an easy thing to guess or to estimate based on obviously by looking at the site. So that's where you need to exercise your engineering judgment when it comes to runoff rate that you can calculate. So for example, as you can see, if I specify, let's say, any random data in here and say, I have 100 time of concentration, obviously the amount that is going to be generated is going to be completely different too if I have a 10, right? So obviously the shorter the time step, or the time of concentration, the more inflow you are going to get, and the longer the time of concentration, obviously the smaller the discharge is going to be. So that's something that needs to be obviously estimated by you, and that's the tricky part. So it's similar to how you would estimate time of entry. You'll have to go through that exercise in your head to say, the time of entry plus time of travel in roughly should be this amount, and that's where the trick is, and it's just an engineering judgment, unfortunately. But the best approach is to always look at modeling the existing drainage system if you can't have information about the existing drainage system.
Okay, great, thank you. Right, we've got probably about 5 to 7 minutes more of questions. Okay, so your thoughts on how to model permeable driveway storage with individual flow controls connected as junctions to the main sewer in the road. I know you can set the point of connection as a junction, but how would you number the pipes?
I think with that, probably try using, I would say try using a boxed a link type, like a rectangular, basically closed section as a link type, so that you'll be able to have obviously the permeable pavings as a link, and then you obviously have the downstream node or junction. You could use a junction instead of a manhole. So that's something probably easier to kind of like model than the typical way of obviously specifying the same node, the same junction. We don't know the junction is obviously, and then specifying the car park on that specific junction at the same time. So if you are struggling to do that, I can show you. So Tony, that's something I can show you, given we have a small amount of time. It's probably easier to kind of like show you that, but I could very quickly like load a file that kind of like does design that as a, basically car park as a link type of design. So I might as well just quickly show you that.
Yeah, why not? Yeah. Any sort of specific queries? There's a support portal that if you're an existing Flow customer, that's just included as part of the subscription. So support.causeway.com, and you can submit a specific question, attach a file type, and then someone will get back to you that way as well. That's always available throughout the
Yeah,
week.
that's definitely available. Yeah, yes. So the car park, you could just use closed rectangular section and specify the dimension and basically make that a link, as we did earlier for the swale and rain garden and so on. So you should be able to do that easily, and that should be essentially represented as a link, and then you should be able to obviously specify the downstream node as a junction. You could actually make that a junction. It doesn't have to be a chamber. So that's something you could do as well.
Lovely, thank you. Okay, next one. What is the best way to simulate an overflow in a storm drainage network?
Overflows are really important, definitely, and you could use offline controls, which are probably the best approach. It should allow you to be able to loop to any point as well. So if you have an overflow and you are basically overflowing into a public open space, you should be able to specify the inver level at that overflow level, and you should be able to use an offline loop. Basically, if you specify an offline control, it should allow you to loop to any point. So you could actually design the public open space like a sport pitch or car park or public park or something like that, and you'll be able to loop to that. So that is something you could do in the software using offline loops. That would be an overflow. And then obviously you could also, because we have Flow Plus that allows you to kind of like design anything you like, you could actually even have a negative backdrop if you like. You should be able to also do an overflow pipe or any link type that you can design as a structure. So if you have like a footpath or something like that, you could actually create the shape of the footpaths to use as a direct, as an overflow, if you like, right? So that's something you could do as well. So it's a matter of basically which way you want to go through like the design. If you want to be too detailed with your design, you could actually create your own shape for where the overflow. If it is something that is going to be footpaths, you could actually create the exact dimension, the widths, and maximum capable depths that could carry or could channel the water. And that's something you could do as a link type, and you'll be able to specify obviously the overflow point, and then create another link basically wherever you want to overflow to. One important point with overflow: if you don't loop anywhere, so you basically specify an overflow control, for example, and you don't loop it anywhere, that water is just going to disappear, because obviously once the overflow goes through the overflow control, there is nowhere it can be stored, right? So it's just going into a black hole unless it is looped to a specific point in a network. So that's basically something to be aware of. But you could do it as an offline control or just as a link, to whichever way you choose, I think.
Okay, good. A few options there. Okay, I think this one came in a few minutes ago, so because I don't recognise it from looking through before the webinar. Is adding urban creep to an area in the current development plan?
It is already there. Let me just quickly show you, given it's easier to explain. So urban creep is this concept about obviously additional contributing area coming into play once the development has gone through the process, basically. So when people start living in their houses, they start, thinking about, okay, let me pave the driveway, or let me build a conservatory, or office in the back garden, or like a shade or something, a garden shade. So that basically increases impermeability, essentially because the modifier rational method assumes obviously that a certain section will be permeable. This idea that it is worth adding additional urban creep factor is something that is important and that's being increasingly required. So if you go to simulation, there's an additional area. So if you are asked 10% urban creep, you'll add it in here. At the design stage, we also have what's called additional flow, which is a similar concept, except that is only used for obviously sizing the capacity of the links using the modifier rational method. So once that is done, you should still be using additional area as urban creep. So you should be able to do that. So that is in addition to a climate change factor, right? So climate change is going to add percentage on the rainfall. Additional area is going to add percentage on your contributing area, basically. So that's something you should be able to do. And again, there's obviously different concepts about percentage impermeability, CV value, etc. I should be very careful about, but given we don't have a lot of time, I cannot get into it. But urban creep is additional area here, basically in the simulation settings.
Okay, perfect. All right, 4 minutes left. Do you think we've got time for one more?
Yes, let's do one more, definitely.
Yep. Okay, how can we design a complex flow control with the discharge rate 1 litre per second for a 1-year event, 6 litres per second for a 100-year event? So around flow controls there.
Yeah, so something that I can show you, hopefully, is, let me share my screen. So with complex control, or what I call compound control, you should be able to have multiple online or multiple, offline, or as many online or offline controls. All you have to do is basically make sure you have the correct design depths and the expected design flow. So if you have basically, as you said, 1 liters per second, you specify the maximum depth you expect for the 1-year return period and specify the 1 liters per second here, and then you go for the second one and you specify the maximum depth you expect for the for the 30-year, 100-year. You specify the maximum design depth here and you hit the calc all button, because what you need to do is make sure obviously both flow controls, because they will be operating until the maximum depths, will be able to kind of like come in play when it comes to determining what type of dimension the second one is going to be. But the second one obviously can be at any point, above the inver level, obviously. So that's something you need to be aware of. Like, you need to make sure obviously you specify it at the expected 1 year inver level maximum depths, and then you'll be able to specify the the maximum discharge that's going to be generated by BOSE. And you don't hit this calc button, you hit the calc all button. That basically allows you to calculate how much discharge is going to be generated with the first flow control and how much discharge should remain to be discharged by this flow control. So that's basically how you do compound flow control.
Okay, fab. That's good. I noticed there was a tiny few second where your audio cut out again as you hit.
Okay.
It was pumping out to the Hydro International website because there's a live link there. I don't know if anyone else had that that audio drop out, but that's probably why. Okay. Should we finish? Yeah. We've got so many more questions, but we'll definitely make sure that we get back to everybody within the next few days, and answer them and send them to the email address that you've registered with. There's obviously support.causeway.com for any specific files as well, or you can contact the email address on the screen there, sales@causeway.com. So yeah, I mean, thank you very much for everyone's questions. They were super interesting. Really glad that you've taken the time out to send those through and shaped the webinar really well. So this is going to be recorded and sent over to you in the next 24 hours. As soon as the webinar ends, you'll get an exit survey pop up on the screen. If you could please take some time, should be only a couple of minutes, just to fill out some feedback, and it's really helpful for us and help us, improve any future webinars. So that would be great. Yeah, Net, have you got anything
Yeah.
that you
Yeah,
want
I
to
just
finish
want to
with?
say thank you so much. Really appreciate your attendance, and please remember to give us feedback on how to improve the software, how to make your engineering life as less painful as possible. And thank you again.
That's great. Thanks everyone, and see you next time.
Thank you. Bye bye.